let us talk about mean value theorem. So the condition is continuity on closed interval and differentiability on open interval. Suppose a function is continuous on closed interval and differentiable on open interval. So for example, we have a graph like this, defined on closed interval, and function is differentiable on open interval from a to b. So then we can expect something nice. So we want derivative of c is going to be slope of this blue secant line. Slope of this blue secant line is, well, this is, so you want to take rise over run. Run is b minus a. Rise is difference between two function values. So we take f of b minus f of a. So this is basically slope of this secant line. So we want to find, there is some certain number c so that derivative at that point is exactly slope of secant line. So for example, there is a point c so that when you look at tangent line, that is exactly share the two lines share the same slope like this. So the theorem says if your function is nice, being continuous on closed interval and differentiable on open interval, then there exists always some certain c on the interval so that derivative is exactly slope of secant line. So this is slope of tangent line. So you can find some point c so that slope of tangent line is exactly slope of the secant line. Okay. So the tangent line at c is parallel to the line. So tangent line, this c to the line joining so the tangent line at c is parallel to the secant line joining 2 points. The line joining 2 points, a comma f of a and b comma f of b. So just the secant line, this blue secant line joining 2 points. Okay, so quick example. We want to answer the question whether this function satisfies the hypothesis of the mean value theorem on interval. Let me pick some interval from 0 to 8. So we have points. Interval from 0 to 8. So on this closed interval, is this continuous? Yes. The continuity condition is good. What about differentiability? Yes, you can take derivative actually, so it's also differentiable. Actually, this type of rational function is continuous on its domain and differentiable on its domain. Okay, and we apply mean value theorem to find number c so that slope of the tangent line is exactly slope of secant line. So let's take a look at the graph of this guy briefly. So the graph, this guy looks like that. So we have 2 points. And then the secant line joining 2 and the points is simply this guy. And we want to find some point C so that tangent line has exactly the same slope like this. So we want to find such a C. Okay, so mean value theorem says that we can always find such point C. So f prime of C is going to be slope of secant line. Well, for the slope of secant line, we look at rise over run. For this rise, we plug in 8. So it's going to be 8 over 12 minus, when you plug in 0, 0 over whatever, over. So this is rise, and run is 8 minus 0. So basically we have 8 over 12 over 8 over 1. So we have 1 over 12th. So we want to find some point C so that the slope is 1 over 12th. We can take derivative of this guy. So on the other hand, derivative of f, well, we can use quotient rule, which is x plus 4 squared. Numerator is some certain difference. For the first term, you take derivative of numerator and copy of denominator. And then copy of numerator and then derivative of denominator. So that is the derivative, and after canceling copy of x, we have 4 over x plus 4 squared. So we want those two guys to be the same. So we set 1 over 12 is 4 over x plus 4 squared. Whenever you have this type of identity, you can take cross multiplication like this. Then we have 12 times 4 equals square of that, x plus 4 squared. So we have certain quadratic equation. So you FOIL or expand the right-hand side, x squared plus 8x plus 16 equals 48. So we have x squared plus 8x. Well, when you simplify this, negative 32 quadratic formula. So x is negative b plus minus square root square of this minus 4ac over 2. So inside radical we have 64 plus 128. So you can simplify this, and then once you take square out, then we have negative 8 plus 8 square root 3 over 2. So once you simplify, we have negative 4 plus minus 4 square root 3. Here we are taking only plus because this minus will give you some number outside this interval. If we are interested in some number only on the interval from 0 to 8, so that's why we are taking only plus. And once you take this square out, we will get negative 8 plus 8 square root 3. And then once you reduce, we have this number. So it turns out that this number C is negative 4 plus 4 square root 3.